Thank you for the introduction. My name is Erez Metula. I'm the founder of AppSec Labs. I'm going to introduce myself in a couple of minutes, but in the meantime, I'll welcome you to this presentation, which is about the top 10 mobile application vulnerabilities. We're going to discuss application level vulnerabilities in Android and iOS. We took those two environments as an example, but the problems that we're going to see today are general and they're relevant to other mobile platforms. So let's talk a little bit about what we're going to see today. We're going to start with an introduction to the Android and iOS application security model. We're going to understand a little bit how the thing works under the hood and how the OS protects the applications, and of course where the OS does not protect the application, and this is where developers sometimes do mistakes, in which when we're doing penetration testing, we usually find vulnerabilities. We're going to talk about the issues and why we should care about application security. We're going to discuss the mobile app threat model. It has a little bit different threat model there compared to a web app, for example. And for the rest of the presentation, we're going to talk about the top 10, the most common vulnerabilities in mobile applications. So a little bit about me. I'm the founder of AppSec Labs. AppSec Labs is an application security company, a consulting company, which is doing application penetration testing. We're doing secure coding training for developers. We're doing the SDL, Secure Development Lifecycle, helping developers how to write secure code and so on. I'm a book author. I wrote a book which is called Managed Code Rootkits. I'm a frequent speaker at Black Hat, DEF CON, RSA, OWASP, and other conferences. Actually, I provide training at Black Hat about Android application hacking. And on my day-to-day work, I do secure coding for developers, training, and of course, penetration testing. So when we're talking about the security model of mobile applications, we need to a little bit understand how the OS and what kind of services the OS provides for us. So let's start with Android. When we're talking about the Android security model, we're talking about an OS. Actually, it is a Linux-based OS that provides the users, in the terms of Android OS, a user is an Android app. It provides the Android app with a sandbox from another Android apps. So, for example, when an Android app is installed on the system, each app has its own user ID. The users, which are the apps, are separated from each other. So, for example, one app cannot access files belonging to another app. An app cannot just, for example, dump the memory of another app. It cannot denial of service another app, and so on. All the apps are signed, so that, for example, if you're downloading an app from the Google Store, they always make sure that you've downloaded and what you've downloaded comes as it was provided by the vendor. So it is doing a digital signature verification on that. And in general, apps are separated from each other. So one app cannot just influence another app. In the iOS world, things are quite similar in general. So we also have something like a separation between apps, and we also have some services in which, for example, the device is locked, and as long as the user doesn't provide a PIN code, the device will still be locked. iOS also provides very good platform level security, in which, for example, the device can auto wipe itself. You can provide the device with assigned configuration files and so on. So in general, it looks like the mobile platforms, it can either be Android or iOS, are secure. And in general, they are secure. I know people are arguing whether iOS and Android, which one of them is more secure. To my opinion, both are good, both are secure. But sometimes developers on both of those environments do mistakes. And this is what we're going to discuss today. So when we're talking about the threat model of a mobile application, we have a threat model which is a little bit different compared, for example, to a web app. And if we take a look at what we see in this diagram, we can see on the left side the mobile app. On the right side, we see the server side of the mobile app. Now, don't get confused. Although it is a client-side technology, a client-side app, still most of the times the client application will probably have a server side. And the server side will contain the business logic of the app. The server side will contain all of the logic related to user authentication and authorization and actions that users are doing on their mobile app is translated to a remote invocation call for the API, for the server side API. So in general, when we're talking about a mobile application, we're talking about the security of what happens on the mobile app, at the left side, what happens on the server side, providing the services to the mobile app, and this is what appears on the right side, and of course what happens in the middle, and this is the third part, which is what happens at the network level, at the communication level. So if we start from left, we are really interested in everything which is related to common server-side security, cloud-level security, about the services that the mobile app consumes. So here we should make sure that the server is, for example, hardened, and we have no vulnerabilities at the API level which is exposed to the world. So for example, if we have in the cloud some kind of an API, a web service, a REST-based API, or so on, we need to make sure that we don't have any, for example, SQL injection or cross-site scripting or command injection and so on. We need to make sure, if we're talking about the communication level, that no one can, for example, hijack the communication, that we don't have a man in the middle and so on. And of course, when we're talking about the client side, we need to make sure that besides of the regular vulnerabilities that might happen at the client side, we need also to make sure that, for example, another app is not attacking our app, and this is something new. This is something that we don't have in a web app. We need to make sure that we don't have vulnerabilities that other users on the mobile side can exploit. So when talking about the top 10 vulnerabilities, we're talking about those vulnerabilities that we see in here. This is what is called the OWASP top 10 mobile vulnerabilities. And let's go and talk about each and every one of them. And I'll briefly describe those so you'll be able to better understand them. So, and just before we start, let me just mention that unlike web apps, in which all you have to do is just usually intercept the communication going to the server side, pen testing mobile apps is more complicated. You will need to reverse engineer the app, you will need to decompile code, you will need to connect directly with the device. You will need, for example, debug a running app and to hook some important function calls and so on. So compared to web app, pen testing mobile apps is more complicated, and it takes a different skill set for the pen tester. So a pen tester of a mobile app usually comes from a web pen testing background, but not all web pen testers are able to do mobile app, mobile app penetration testing. So there are two tools that we developed for that. One is called AppUse for pen testing Android apps. It is a tool developed by AppSec. And another tool called Analyzer. Both of those tools will allow you to pen test mobile apps. I will provide the links for them later on the slides. So just be aware of that there are tools that we developed that will allow you to better pen test your apps. So let's start with number one. Number one is the weak server-side controls. And in number one, we are after vulnerabilities in the functionality that the mobile app is using when it is communicating with the server side. So usually the important stuff, the important logic happens at the server side. So in order to test the security of the server side, what we usually do, we usually insert a proxy between the mobile app and the server side for the purpose of analyzing all of the communication that is going on between the client and the server. So we're analyzing the communication that is going back and forth from the device to the server side. And here we are after server-side vulnerabilities. And in here, it is quite similar to pen testing a web app. And in here, we are talking about doing some authentication bypassing. For example, authenticating or spoofing the identity of the mobile app user and spoofing it to another user identity. We're talking about vulnerabilities such as SQL injection. So, for example, we're intercepting a request coming from the device, we're intercepting it with the proxy, and then we're doing some parameter manipulation, and we're embedding some SQL commands so that eventually the server side, the business logic of the server side, might embed it inside a raw SQL query that might influence the database. This is really important because although it is considered a classic web app attack or a classic server-side attacks, it is really important to cover this kind of vulnerabilities in mobile apps. So in general, when a penetration testing of a mobile app happens, you really need to make sure that the server side is covered as well. Second problem that we see when we're pen testing mobile apps is vulnerabilities that are related to insecure data storage. Now, in insecure data storage, we're talking about the data that the mobile app saves on the mobile device. Now, unlike other computing environments, a mobile app runs on top of a mobile device. The mobile device is something that, well, since it contains lots of secrets, this is something that attackers might be interested when we're talking about the physical access of a device. For example, stealing a device just for the purpose of getting to the data. This is something which is a little bit harder when you were talking about a desktop device, because mobile devices are devices that people tend to leave on their desk. They tend to forget them somewhere, and well, it can be easily stolen compared to other environments, other computing environments. Now, in mobile devices, also, since we don't have, since using a mobile device in mobile applications, they tend to have less authentication burden on the user. So compared to an equivalent, for example, web app, many times the application is doing an auto login. You're not required to do a login when you're using the app. So the app is storing lots of information. It stores like usernames and passwords and encryption keys and credit cards and session tokens and so on. We are talking about PII information, private information. Sometimes we're talking about PHI information, which is health-related information and so on. Sometimes we're talking about a geolocation, like the location that the user was using the app and so on. And this is quite sensitive. Now, the places where the application stores this information is usually in the app folder. It can either be in a file, it can be in the SQL database that the application has. It can be stored in XML files, and sometimes even on the SD card, or maybe remotely on the cloud. But the issue here is that many times the developer is not doing that much of a good job for protecting this kind of information. For example, sometimes the developers don't give very good permissions on those files. So, for example, you end up with an application that might store sensitive information in a folder that other app can access. Now, if we take an example from the past, lots of applications had this kind of vulnerabilities, and one of the famous ones is Skype. Skype had a problem like this, in which other apps on the same device could look into Skype files and look into configuration of Skype, hijack the user, and so on. Maybe hijack some sensitive messages that the user was using. But in general, this is a big problem. So having files with bad permissions is a bad idea. Storing files on the SD card is also a bad idea, because SD card has the security model of the SD card well, compared to the other places in which the app can store, the SD card is the less secure place to store the files. So the SD card has less security. SD card is something that you can detach from your device. So in general, storing files on the SD card is a bad idea. And we sometimes find vulnerabilities that are related to insecure file storage. And this is really a big problem because other apps on the same device can steal it. For example, think about this scenario. You're installing an app. You're thinking that you're installing something, let's say, something innocent like a calculator, a weather application, or something like that. And the app is providing you the services that you think it is providing you, and it is providing you the calculator services. But in the background, it is stealing sensitive files from other apps running on the same device and send it remotely to the attacker. This is a really bad problem, and we have lots of Trojan apps on the stores that are just doing that in the background without the user ability to know about this kind of thing. Problem number 3 is insecure transport layer security, or in other words, no usage of HTTPS. Now, when we are using HTTPS, well, let me start with that. When you are not using HTTPS, when you are using HTTP, all of the communication can be hijacked. The attacker can redirect the communication. It can make the mobile app thinks that the app is talking with the real server while it is talking with a man-in-the-middle server or maybe some other server. The user can modify the communication. It can inject false information in the communication. The attacker can also do replay attacks and steal the user credentials and so on. So, in general, when we are talking about an app, from a security point of view, a mobile app that is not using HTTPS, is not just using HTTP, is not considered a secure app because everything which is related to the communication of it can be hijacked. So the idea is that we are requiring mobile apps to use HTTPS. Now, HTTPS provides you with the ability to encrypt the transport and also to authenticate the server side. Now, the problem is that even if the application is using HTTPS as the transport layer, sometimes we find out that the developers just disabled, the developers of the mobile app disabled the ability of the mobile app to check for the certificate validation. And it happens many times when, for example, we have an app and the app is using a self-signed certificates, and we have self-signed certificates due to the fact that now we need this certificate. We're writing an app. We don't have the production, the certificate that will be used at the production environment, at the development environment. So we're using something which is self-signed, which is okay. But the problem is that if you would like to use a self-signed certificate, you will need to disable certificate validation, like you see in the code that appears on the screen. Now the problem is that it is okay for using this kind of thing at the development environment. But when this kind of app happens at this production, then, well, you end up with an app that even if it is using a good certificate, a valid certificate, it doesn't check for the authenticity of the certificate. And the meaning is that even if the app is using HTTPS, still the attacker can man in the middle the communication. He can replace the certificate with his own certificate, and by this he can man in the middle the communication and decrypts the communication. So this is really a bad idea, and we find lots of applications for the pen testing that we are doing that have self-signed certificates. So watch for that. Problem number 4 is unintended data leakage. In unintended data leakage, we're talking about information that the developer didn't really realize about the info that they're saving, either directly or indirectly as a side effect, so that later on this information can be abused by an adversary. For example, caching of URLs. If, for example, the user is using some URLs that might be sensitive, those URLs might be cached, and the attacker can exploit that. Keyboard caching, copy-paste buffer caching, backgrounds of the application that might have sensitive information on the screen, logging, and so on. All of those are examples of data that the attacker can abuse. And a real-world example happens most often on logs. Sometimes when we are doing pen testing, we look at the logs of an apps that we're pen testing, and we sometimes look for treasures that are hidden inside logs that the developers wrote to the log. The idea was to save information to the log for later analysis, but the problem is that logs might contain sensitive info, such as values of sensitive variables, such as encryption keys, serial numbers, credit cards, passwords, and so on. So it is really a bad idea to save sensitive information in logs. And let me just emphasize it, and let me just make it clear. Besides of the fact that it is a bad idea to save sensitive information inside log files, you sometimes violate your regulations, because regulations clearly say that you are not allowed to store sensitive information in logs. So be careful about that. Now, this is an example of a log file of an app that we pen test. We did a pen test, and in the pen test, we just figure out that there is a session ID stored in the log, and it allowed us to just do a hijacking and to do session hijacking, but just reusing the same session ID that we took from the log file. Now to problem number 5, we're talking about poor authorization and authentication. Now, in this area, we are looking at functionality that we usually have on the server side, in which the user, the attacker, can abuse in order to make the app think that he is another user, or in order to make the app think that he is allowed to do something while it is not allowed to do so. And many times we see problems that are related, for example, to bad authentication schemes. For example, if we are talking about the password complexity of a mobile app, most often it has a less complex or less amount of possible combinations for the user to select a password. And the reason is that, on a mobile device, the user has less options on his virtual keyboard. So we cannot just select the whole special characters, for example, that he has on a regular keyboard. So we end up with very easy passwords, and those easy passwords can be brute forced quite easily. So we see apps with brute force capabilities or that can be brute force. We see apps in which even if the password is complex, there is no anti-brute force on the server side. For example, we see no locks after a specific number of attempts. We don't see anything like a CAPTCHA, which is quite common on the web app, but it's not that common on a mobile app. So no CAPTCHAs are being used. CAPTCHAs are usually being used as an anti-automation mechanism. So in general, we see lots of problems related to that. Now, another problem which is related to that is the fact that mobile apps are sometimes using a device identifier such as IMEI, IMSI, and so on to authenticate the user. And this is also a bad idea because this is something which is quite easy to forge. So many times we were able to spoof our identity just by making the app think that the device has a different ID than the original ID. For example, tampering with this value and changing it to another user so that the server side will believe us. Problem number 6 is related to cryptography. Well, when we are talking about broken cryptography, or what we call it in the security industry, an encryption, we're talking about cryptography which is been just done wrong. Now, having bad cryptography is even worse than having no cryptography at all, because the developer thinks that he's protecting the value, but actually is protecting the value with bad cryptography, with cryptography that can be easily broken. For example, hard-coded keys stored in the source code that can be easily decompiled. Same key, for example, which is used for all of the users. If one of them is the attacker can use the same key, and he knows that the same key is shared by other users, so he can just broke it. Keys that can be stolen from the app due to bad permissions, a key that is stored right next to the encrypted key. Sometimes we see just bad cryptography that the developer invents. For example, he thinks that by taking the strings, shifting a couple of bits, doing XOR with that, or whatever he's doing, he has something that no one knows about. That actually this is really bad. So just to give you an example of how bad it can be, the places that contains crypto logic, like pieces of code that contains the actual logic of the code, is really dense in terms of security vulnerabilities. So in just a couple lines of code, we have lots of vulnerabilities. And let me just give you an example for that. For example, we have here a problem in which we have a hard-coded key. In this line, we have a problem in which we are using a bad algorithm, which is the DAS, DES. Nowadays, DAS is considered as an obsolete algorithm. The actual algorithm which is recommended as a symmetric algorithm is AES, so DAS can be broken quite easily. Another problem is mode. We're using ECB. And in ECB is a bad idea because each of the blocks is encrypted the same. So well, we can quite easily broke the encryption scheme and so on. So just in this lineups of code, we can see that we have lots of problems. So in general, when we have security vulnerabilities, they're usually scattered among lots of code. We usually find one line of code containing vulnerability, for example, in one class. But here we have 3 vulnerabilities in just about 10 lines of code. So this is really bad. Problem number 5 is client-side injections. And in client-side injections, quite similar to server-side injections, but now we're talking about injections that happens on the client side, at the client side. We're talking about injections that, for example, happens when one app is sending information to another app on the same device. And this is something that we don't have in web apps. Now we're talking about apps that or about attacks that happens solely on the mobile app. The server side doesn't even know about it. So we're talking about apps that it's attacking in other apps. We're talking about injections in files that the app is consuming. So for example, the app is opening a file, a shared file on the SD card, and then it reads some value, and then we have an injection on the server, on the client side, and so on. So for example, SQL injection on the client side. Again, quite similar to server-side SQL injection, but here we're talking about an injection to the local database, the local SQLite database that mobile apps have. So we have, for example, an external input that is embedded inside SQL query. We're talking about command injection, in which external input is just appended to the end of another command, and the attacker can add, for example, a semicolon and add a new command, introduce a new command to the OS. We're talking about directory traversal attacks, in which the app thinks that is opening a file, but actually it's open another file, due to the fact that the file name might contain .. and so on. We're talking about vulnerabilities such as XSS or JavaScript injection, same like we have on the server side, but now we have it on the client side, and so on. So it's quite the same thing that happens on the server, the same pattern, or let me say anti-pattern that happens on the server side might happen on the client side. Problem number 8 is security decisions that happens via untrusted inputs. Here we're talking about the fact that the app might consume information, same like we have in the previous one, but here we're talking about the fact that apps can communicate with each other and they can send messages to each other, so apps can somehow abuse the function functionalities of another app. For example, if an app has developed a component, for example, that is doing encryption or decryption or whatever, and this component was developed for the purpose for the app itself to consume it. So for another component of the same app to use this component, but the problem is that if this component is exposed to external apps, so external apps can communicate and invoke functionality of the app. And this is a really bad idea, and it happens on Android and on iOS. This problem is a little bit more it happens a little bit more on the Android, but just due to the fact that Android has a richer model, it allows apps to communicate with each other. So we see this problem more often in Android, but we also have this problem on iOS, in which we have, for example, a URI scheme, so that an app registers an URI, so the user just happens to click on a link and then it is transferred to another app. So problem number one is improper session handling. And in here we're talking about well, due to the fact that the app needs to maintain a session, a session to the server side. Now, the protocol is stateless. Usually, we're using HTTP. So, so in order to enable the app to communicate with the server, usually the server provides the client with some kind of a session token. Now the problem is that those session tokens are not handled properly on mobile apps. For example, if I compare it to web apps, in web apps, the web give the user the browser a session ID. It is saved in the cookie, and that's about it. The developer doesn't need to do anything about it. But in mobile apps, it is up to the developer to write extra code to handle it. And in this extra code, sometimes vulnerabilities happens. For example, the token is not created in a secure manner. It's not properly, well, it doesn't have a pseudo-random generator for that. The session is not validated correctly on the server side. Sometimes we see inadequate timeout protection, so that instead of having a session that is valid for 10, 20 minutes, maybe an hour or so, we see sessions with session timeout, for example, 1 year or something like that. And in general, rotating the cookies or the timeout is something which is done improperly on the mobile app, and this is something that you really need to take care of, because many of the vulnerabilities happens at the session management part of the app, and we figure out that this is a hotspot that must be tested correctly. Problem number 10 is lack of binary protections, and the idea is that since we're giving the user the user can just decrypt it. The user can take the code, he can analyze the code, and so on. Unlike web apps, and in web apps we don't give the user the code of the app. You don't have the server-side logic. In mobile app, we give him the actual code of the client side. So, and since the client side is doing sometimes very interesting things, the client can just, the attacker can just decompile it. So in general, the idea is that we need to make sure that no one can decompile it, or even if he decompiles it, he doesn't find any interesting things on the code. Interesting things might be secret, or what is considered secret algorithms, or business logic that happens to run on the client that we wouldn't like the user to see. We might have vulnerabilities on the code, on the mobile side code, that the attacker can just decompile and figure out it by just going over the code. Or we might have secrets on the code, or maybe something which is related to piracy. People can take the code and change it and maybe just pirate the code or pirate the app and use it without paying any for any license or so on. And of course, if the code can be decompiled, it can be modified. And we sometimes find apps that have code modifications or backdoors that are inserted into the original code, or the logic that is being changed and so on. So it is quite easy to reverse engineer apps. It's quite easy to do mistakes by not protecting the app correctly. So in general, when people are decompiling the app, well, it ends up with something which is obfuscated. Yeah, well, but the best thing can be done is to use some kind of, well, first thing is to use some kind of an anti-decompilation utility. But the best tip that I can give is that, well, whatever you will be doing as a developer, decompiling an app will always be possible. So the best thing to do is just make sure that there is no sensitive logic at the app, because eventually everything can be decompiled and everything can be analyzed. So we just saw the 10 most common vulnerabilities related to mobile apps. Um, um, that was the last topic related to the common vulnerabilities. So let me just summarize this session. As we saw, mobile app vulnerabilities are not related just to the mobile app, to the mobile application, to the client application. We're also talking about the client and the server. And in general, mobile application vulnerabilities put the whole system at risk. It puts the mobile app at risk, it puts the server side at risk, of course the end user, and of course the organization that is providing the mobile app service. So we need to make sure that everything is performed accordingly and we don't have any security vulnerabilities. Always remember to not take security decisions on the mobile app. So if you're developers, make sure you're not doing any security decisions at the client, because it can be patched. And if you're a pen tester, if you find security decisions at the client side, it usually means that you find a vulnerability. So, and this is something which is a place in which you need to take a deeper look. Always remember that a mobile app is something like an open source code, and the reason is that it can be decompiled quite easily. So a rule of thumb is, if you remember then that the mobile app is like an open source code, you will probably avoid doing stupid things, right? Security-wise. It is quite important to integrate security into the development lifecycle. This way, you're making sure that security vulnerabilities are not just, well, instead of finding the security vulnerabilities when the product is already being developed, it will be better to just look for security vulnerabilities and design security mechanisms right when you start developing the app. So, for example, if you didn't even write the code and you're just at the design stage, but you design it in a secure manner, it will be better than, for example, the coding it, developing it, and then find the security vulnerability. And of course, it's really important to pen test an app, especially if it's out there on the mobile app at the mobile stores. Because if it's on the store, it means that, well, people are looking at it. I even guess that people are looking at a specific app when we talk. So so if the app is on the store, it's quite clear that well, people will eventually take a look at it and find vulnerabilities in it. So I invite you to use and download our free of use tools that we developed. We developed those tools for our purpose as penetration testers, but then we decided to open it up for the general public to download. So you can download AppUse, which is an environment for pen testing Android applications, and Analyzer for pen testing iOS applications. And I hope that you enjoyed this session. If you have any questions, I'll be more than happy to answer them. Of course, we'll have now a couple of minutes for the questions, and of course, if you just remember about something that you'd like to ask me, feel free to ask me. This is my email. Feel free to contact me and talk about this or maybe other things that you would like to discuss. And of course, thank you very much, people. I really enjoyed it, and I hope that you enjoyed that too. Thank you.
All right, Eric, thank you so much for such a such a just very, very rich content, and knowledge and expertise presentation. Really, really appreciate it. So as Aries is presenting, it's almost like deja vu for me. I mean, I remember when I first got into information security 20 years ago, and I mean, it looks like we're kind of shifting vulnerabilities or problems from one platform to the other. And I'll explain what I mean. When I first got into security, firewalls were a luxury. We had to convince a lot of CEOs, a lot of directors of IT that they needed a firewall, right? And in some cases, they actually bought a firewall, but it was an expensive tool. They didn't even have an access control policy. Security is about people, process, technology, and I would even add one layer, which is data, because now data is everywhere, right? So in my CISO roles, I always say what you don't know can hurt you, and you're better off knowing what you don't know, right? So doing a penetration testing, to me, is just part of doing the right thing and doing due diligence, or showing due diligence and due care. For any CISO and their team, if you find yourself responsible for, applications, period, whether it's mobile apps or, cloud-based apps or even on-prem apps, web apps, a penetration test, in my opinion, is a must-have as part of your overall strategy, especially for a CISO. So I think a lot of things that have been shared here, I think we've seen the same vulnerabilities play out, when we didn't even have mobile apps, right? We're just seeing a shift now to the same things or the same vulnerabilities manifesting in the mobile app platform. In my day job, currently, I am part of a startup that rates cloud service providers. So we rated pretty much hundreds of cloud service providers. Now we're trying to scale that to 10,000 plus, including SaaS apps, running on those major cloud platforms, right? And one thing I'm finding is, cloud could either be a disaster or it could be the best thing that happens to cybersecurity. And a lot of the cloud service providers have invested very heavily in cybersecurity. They're able to scale, not only their operations and infrastructure, but they're able to scale, their security expertise. And so that could be a big benefit. But, customers still have a responsibility to do the right things. So, what I'll just say is what you don't know can hurt you, and you want to know what you don't know by engaging a company like AppSec Labs to do your pen test. And these guys do a really good job as well. So anyway, that's my plug. I noticed that we opened up our poll. It's just a simple 2-question poll a couple of minutes ago, I think about 5 minutes now. So while you guys are submitting your questions, via the question link, I'll just really encourage you to take the poll. It looks like we're currently at, I would say 47% have taken the poll. If I can just have the remaining of you take it, I appreciate the ones that have taken it. We're going to share the results at the end once the poll ends. But in the meantime, please send in your questions. Ronan and I are still going to be here, especially directed to Ronan because he's the expert. And then we'll share those, and then Ronan would take a stab at answering those questions. So we still have a few minutes remaining, roughly 10 to 12 minutes. So take the poll and then send in any questions that you may have in the meantime. Ronan, did you have any thoughts, anything else to share with us, maybe to kind of follow up to what the comments I just made earlier? I'm sorry, Aries.
Oh, sorry, I was on mute again. Can you please repeat the question?
So I'm just saying, do you have any follow-up comments to what I just mentioned while we wait for those who haven't taken the poll to take it, as well as waiting for questions to come in for you?
Well, yeah, I think that, well, I totally agree with what you said. It is, people think that mobile app are a new technology and we're talking about new vulnerabilities and so on. Well, it is, well, the things are quite similar to traditional security, like the same vulnerability, the same problems that we encountered 10 or 20 years ago in security. We see it today. The technology is a little bit, it's more advanced, of course, but we have the same vulnerabilities that we had before. We have them again on the server side. With an additional vulnerabilities that are related to the mobile side. So just to put it in these words, when we have mobile app vulnerabilities, it's like having the whole set of vulnerabilities that we have in web app plus another set of vulnerabilities that are related to the extra exposure that the threat model of a mobile app has. So in general, mobile apps are more dangerous than their equivalent web app.
I would actually coin the phrase we're cloning the same vulnerabilities on the mobile app platform. And then you obviously have the API, the exchange, which even makes it more complicated. But it's still the same principles, right? I always say vulnerability management is no different from what we do every day. We leave our homes every day, and hopefully we close our doors, we close our windows, and we make sure we don't have any step ladders, laying around on our front porch or backyard or garden, right? That's basic vulnerability management. We turn on an alarm system. So if somebody were to break in through the door, through the window, we get some sort of, emergency, some sort of response. Maybe it's from police or it's from the monitoring center. I mean, it's the same concept, right? So, you talk about VPN, right, or encryption or data transfer. I always say a VPN tunnel is like creating a tunnel between your neighbor's house and your house, right? If you want to create a tunnel like that, you want to make sure there's a gate at both ends. And you want to make sure you've locked away all your valuables, right? I don't know about you, no matter how much you trust your neighbor, you still don't want to give them carte blanche access, to everything. So it's the same principles that we follow in day-to-day life, but for some reason in cyberspace, we kind of feel they don't apply, but it's still the same basic principles. But I like to pretty much coin the phrase, we've cloned the same vulnerabilities from web platforms to mobile apps, and then the data exchange even makes it even more an opportunity, for the bad actors to access sensitive data.
Yeah.
All right.
Totally agree.
Excellent.
Well, thank you, Ty.
No
thank
problem. We don't see any questions yet. I'm not sure what's going on. I think you did such a great job, Aries, at actually presenting your session.
Thank you. Thank you for presenting me, and thank you for having doing the whole setup and invitation. I really appreciate that, Ty. So thank you, everyone. I hope that you enjoyed everything, and see you again for the next time. Thank you.
All right, Aries, just before you go, can you just show up the last slide that has your email address? If there's any follow-up questions, they can email you. Just quickly, I'm going to share the results of the poll. I'm just about to close the poll, and yeah, it's just been closed. So 67% actually voted or participated in the poll, and 63% said yes to question number 1, which is, question number 1 is, are you responsible for any mobile applications? So 63%, which is 2/3 of attendees, said yes. And then the second question, which is, have your mobile applications been tested for security vulnerabilities in the past year? 38%, which is very interesting. So 1/3, roughly 1/3, said no. So, obviously you guys can form your opinion from that. But, I think there's obviously some gaps here. And I know AppSec Labs is in a very good position to help address those gaps. So on that note, Aries, thanks for your time. Thanks for sharing your knowledge. And thanks for all the attendees that participated in the webinar. There's going to be a recording link that would go out to everyone that registered, including those who actually missed, participating in the live event. Watch out for that. Keep an eye out for that. Thank you very much, everybody, and we'll give you 5 minutes back in your day. Aries, unless you have any final statements.
Well, no, I just would like to thank everyone for attending this session, and of course, if you would like to help us with doing penetration testing, we'll be more than happy to do that. Thank you, everyone.
Excellent. Thanks, Aries.